Alright, this is iChem 21 on limiting and excess reactants. We did a little bit in class today exploring this idea, and now we're just going to put some definitions and some calculation notes to the ideas we developed in class. So first let's start with kind of a real-life example to orient you. We talked about before chemical reactions are just like recipes, right? We talked about the stoichiometry recipe if we're making cookies, and here's another example for a lemonade recipe. Based on a recipe, we can write a balanced equation. And I'm just going to kind of abbreviate this here. I have, to get my pointer ready. We have 4 cups of water plus 1 cup of sugar plus 1 cup of lemon juice yields or produces 1 gallon of lemonade. So let's say your coworker mixed up the grocery list and didn't buy all the right amounts to make a set recipe. He bought 6 cups of water, 16 cups of sugar, and 16 cups of water, 6 cups of sugar, and 6 cups of lemon juice. Now we need to figure out how much lemonade you can actually make. Well, if I base it on water, if I have 16 cups of water to start with, I know that for every 4 cups of water, I can make 1 gallon of lemonade. From all 16 cups of water, I could make 4 gallons of lemonade. Okay, this is assuming that I have plenty of sugar and lemon juice to go around to accomplish that. If I started with 6 cups of sugar, from all 6 cups of sugar, I could make, for every 1 cup of sugar, 1 gallon of lemonade. So I could make 6 gallons of lemonade. And finally, I had 6 cups of lemon juice, knowing that from every 1 cup of lemon juice, I can make 1 gallon of lemonade. I could make 6 gallons of lemonade. If we compare all of these numbers, we notice that the number for water is smaller. Intuitively, you would say, because this makes total sense, when you're working in the kitchen, that you can't make 6 gallons of lemonade because you only have enough water to make 4. So you would be able to make 4 total gallons of lemonade, and you would have to have some sugar and lemon juice left over. So let's put some chemistry-based definitions to this. The limiting reactant is the reactant that will run out and stop your production. In the case of this example, it was water. Water runs out after making only 4 gallons of lemonade. Next definition is excess reactant. It's whatever remains, whatever reactant's left over after the production stops. So you use up all of your limiting and you have some excess left over. That's your sugar and your lemon juice. The theoretical yield, the amount of product expected to be produced with reactants available. So in this case, it's how much lemonade could I make with given what I have available. And that's 4 gallons of lemonade, because the water will run out after you make 4 gallons. It doesn't matter that you have enough to make 6 gallons of enough sugar and lemon juice to make 6 gallons. So this is called theoretical yield, remember though, because we're not perfect. We might spill a little bit out and end up with 3.96 gallons of lemonade in the end, which is how real life works. Now let's look at the example from class today and apply this to a chemical equation, this idea to a chemical equation. What you'll see in a limiting reaction reaction problem is you'll, instead of having one given and one unknown, now you'll have two given. So you'll be getting information about two substances and asked about one. Two givens, one unknown, that tells you that it's a limiting reactant problem. It doesn't change much about how you go about it. It just changes how many calculations you have to do. So let's look at our reaction in flask 1 from today. Remember, we reacted magnesium with hydrochloric acid and formed hydrogen gas and magnesium chloride. In a balanced equation, this gives us 2 hydrochloric acids for every 1 magnesium here. Okay, so this is clearly a limiting reactant problem. I have information about 2 substances, 1.22 grams of magnesium and 0.05 moles of hydrochloric acid, and I'm asked about 1 unknown, volume of hydrogen formed. So what I do is I solve 2 stoichiometry problems side by side to find my unknown. So in the first one, I'll be going from 1.22 grams of magnesium as my given to liters of hydrogen as my unknown. In the second one, I'll be going from 0.05 moles of HCl to, again, liters of hydrogen as my unknown. From this point, once you've identified that you need to solve 2 problems, it's really just basic stoichiometry. So let's solve the first one. 1.22 grams of magnesium. I want to get to liters of hydrogen. Before I can use my balanced equation, I need moles. So divide by the molar mass. I have grams here, I put grams there to convert to moles. So the molar mass of magnesium is 24.31 grams per 1 mole. Okay. Now I need to convert from moles of my given, moles of magnesium, to moles of my unknown, moles of hydrogen. These numbers, remember, come from the balanced equation. So in front of hydrogen, I have a 1. In front of magnesium, I have a 1. For every magnesium I react, I make 1 mole of hydrogen. Finally, to go from moles of hydrogen to liters of hydrogen, I need my molar volume, 22.4 liters per 1 mole. Let the units guide you. Put the units in and then the numbers to identify the conversion factor you need. I plug this all in. 1.22 divided by 24.31 times 1 divided by 1 times 22.4, and I end up with 1.12 liters. Now I do it all again, starting from a different given. Same unknown, different given. Now I'm starting from moles of hydrochloric acid. That means I don't need this first step. That step with the molar mass is to get from grams to moles. I already have moles. I'm going straight to mole ratio. Moles of HCl, my given on the bottom. Moles of hydrogen on the top. And fill this in from the balanced equation. 1 mole of hydrogen for every 2 moles of hydrochloric acid. And finally, moles to liters of hydrogen gas, 22.4 liters per 1 mole. If I plug this in, 0.05 divided by 2 times 22.4, I end up with 0.56 liters of hydrogen. Okay, so now I want to answer these questions, and I kind of wrote over them by accident. But first I need to identify my limiting reactant. Which one am I going to run out of first? So just like we did with the lemonade example, we're looking for our smallest number. From the 0.05 moles of hydrochloric acid, we can only make 0.5 liters of hydrogen, because we'll run out of hydrochloric acid after that. So my limiting reactant, look here for the smallest number, and I look back and identify hydrochloric acid as my limiting reactant. Okay? The theoretical yield is whatever I make from the limiting reactant. So this is my TY, my theoretical yield. My excess reactant is which one am I going to be left over? So come up and find the big number. And before you go over here to magnesium, I want you to do something for me. Cross out your answer to this number. It's really important here. When this number never exists, we can't make that much. We're starting from 0.5 liter, we're starting from 0.05 moles of hydrochloric acid, and the most we can make is 0.5 liters of hydrogen. This number never existed. Cross it out. So now we look back and we identify magnesium as our excess reactant. This we will have magnesium left over, and we saw this today in the reaction. There was magnesium left at the bottom of the flask in flask 1. So the excess reactant is magnesium, and another question you can be asked is how much is left? To figure out how much is left, we got to go back to what we know happened. We know that all 0.05 moles of hydrochloric acid reacted. We ran out. So I know that 0.05 moles of hydrochloric acid reacted. I can find from this magnesium reacted. Another basic stoichiometry problem. So now I'm going from moles of hydrochloric acid to grams of magnesium. So convert from moles of hydrochloric acid to moles of Mg in the balance equation. That's a 1 and a 2. And then from moles of Mg, I can find the grams of magnesium also reacted using the molar mass. Do 0.05 divided by 2 times 24.31, and I get 0.61 grams of Mg reacted. But the question is, how much is left? So this is a simple difference subtraction problem, right? I started with 1.22. I used 0.61, so 1.22. I used 0.61. How much is left? 1.22 minus 0.61 gives me 0.61 grams left. Now in this particular case, you end up with the same amount left as reacted because the numbers, the way I did them, was just doubling the amounts from the stoichiometric ratio, the 1-to-1, just enough of each to complete the reaction. That doesn't mean that this step isn't necessary. Once you find the reacted, subtract it from how much you started with, and that gives you how much is left. We'll practice more of this in class tomorrow. Do not forget to do your Google form.